Okay, the first things I want to talk about then are two things relating to coursework. Let me share my screen. The question in the chat from Zia was, is Mahara back up and running again? The answer is no, Mahara is not back up and running again. And I now think we can't rely on Mahara being up and running for the ePortfolios exercise. So you'll remember 2 weeks ago in class, we talked about running ePortfolios through Microsoft Teams and the class notebook. And that's what we want to encourage everyone to do now. It's a switch of software for where we host the portfolios. And what I've done is to create, you'll see this presentation or this file to be the second thing you see in coursework 2. And it looks like this. And it's just a guide for anyone who didn't quite follow it when we went through it in class, just how to produce that portfolio in Teams. So the important thing here hasn't changed. It's about the work you've done in Fusion in particular throughout the year. But then the way you show that work to us has now changed, and we recommend you use the class notebook in Microsoft Teams. And this document kind of just explains how you do that. So it's fairly step by step of like where to click on the Teams page and things like that. You should do it under the space that's under your own name. So you'll see things like a collaboration space. Don't do it there, otherwise we won't know it's your work. Do it under the space in class notebook that's listed with your name. And then the key buttons really are this show navigation button, this add section button, and this add page button. So that's where to look. We've included a sort of brief reminder about things you might want to do with your portfolio at the end. So I do recommend everyone takes a look at this document. A lot of it is about deciding, taking all the things you've done in Fusion, which you've been doing all through the year, and then deciding how to fit them together in the document. And then there's some final advice about things like try and make sure it looks impressive. Remember that we've used a kind of way of understanding this of thinking about employers quite a lot. So if in doubt, think about what would look good to an employer, what would sell me as a strong candidate for a particular job I was interested in, and then try to do that. And again, there are lots of examples on the VLE on this coursework 2 page down at the bottom of previous portfolios. And if you look at those, again, you'll start to see some of the things that we might like you to do. And I guess it's worth saying, you know, you should feel free and encouraged to do new things. So in particular, we won't know all of the functionality in the Microsoft Teams class notebooks. And if you find something really cool or like a way of linking to something that you think is great, then we'd love to see that. I can see a couple of questions from Jake in the chat. What text size and image size do we do? That's really up to you. How you lay things out is up to you. I guess maybe what I've got on the page here, if we critique it, this is okay, but it was my first draft of things. Now that I look at it laid out on the page like this, maybe the text is a bit small. It's quite hard to read even on my bigger screen. So maybe I should have made that text a bit bigger. Maybe I could just align things so they look a bit neater. And so, you know, in a way, that's how I would approach the first question from Jake, is not we insist on 12-point text size or anything like that. It's what looks good to you on the page. What do you as a designer want to show? And that is what's important to us. So graphical communication in a way is what we're interested in. Do we combine all tabs together at the end, or do we keep them all separate? Not quite sure what you mean by all tabs. I've got here, if you look on this page, let me just zoom in a bit so we can all see that a bit more clearly. If we look at this screenshot, we've got one section divided up into 8 pages in our example portfolio, and I think that is about the right way to do it. And it would have been the same in Mahara, of one Mahara portfolio divided up into about 8 pages. So there's no need to combine the pages in any way. You know, if I just go, let me zoom back to normal, and then if I just go back, so for example, this was an image of what my part modeling page looks like. And you can see all of this on Moodle. I haven't filled in all the pages, but I've filled in some. And then this at the bottom is an image of what my engineering analysis page looks like. And those two are, you know, separate in that you have to look at them separately. So that is the ePortfolio coursework. You still have quite a long time to keep going and getting this all right. It's due in on the 23rd of March, which is 2 weeks today. So that is just worth going back through the brief again and reminding yourself of all the detail in the brief before you start putting it together and making it look exactly like you want to. Any more questions on Coursework 2 and the IMechE, sorry, and the ePortfolio? Okay, we can come back and sort of think about that again at the end if people want to come back and ask more, and we'll talk about it again next week as well. So the other thing that I wanted to talk about in terms of coursework is coursework 3, the Fusion exam. You will now be able to see your outcome from the Fusion exam. I hope. Lots of people did very well indeed. We marked it on a pass refer basis, but there's also an option to take it outstanding, and some students we marked it as outstanding. That won't show up, I'm afraid, in any numerical marks at the end. It is just pass refer as we talked about, but you can have the personal satisfaction of knowing that your work was really of a very high standard, and a number of other students were pretty close to outstanding, I would say. So, you know, don't feel disheartened if you think you'd done a good job and didn't quite get an outstanding. That's also quite possible. Some students will see that you've been referred. Generally, I would say that happened to students who only got as far as producing the 2 numbers. And then the maximum we could give you would have been 40%. Because you'd only done 2 of the tasks. I'll just remind you of that in the brief here. If you only did the part modeling and the sculpting, that's just 40% of the marks available via the brief. You wouldn't have got any marks for sheet metal, wouldn't have got any marks for assembly work, and then maybe you might have got some marks for materials and appearances, but you know, that was typically where people weren't quite making it to the pass mark. If you've been referred, I will be emailing you this week to tell you how you now go on and pass. So we don't want this to become a long-term obstacle for anyone in the module. We want everyone to be able to show the evidence that they can use CAD successfully, and we'll let you know how to do that if you haven't passed yet. And to those of you who have already passed, congratulations. Any questions on that CAD work and the CAD exam and coursework 3. Okay, I'm only hearing silence and nothing in the chat. The answer is no. There won't be detailed feedback on given formally, but if anyone wants feedback, email me and I'm happy to give you more feedback.
Could I ask a quick question on the portfolio? I don't know if my chat went through.
I haven't seen it. Sorry, maybe. Yeah. Anyway, ask away, Floyd.
Yeah. I was gonna ask for a section on drawings, if we can include it. Did you mean like only CAD drawings or like a mixture of CAD drawings and hand drawn sketches?
Yeah. All of those things can and should go into the portfolio, and I guess I think I'm just going to bring back the list. I think when so there isn't on the list of our suggestions, it doesn't actually say drawings, but maybe it should. So I would say you could easily have a page specifically for CAD drawings, like the kind of drawings you get out of Fusion. And you could include sketching for any of these things. You know, you've almost certainly done some sketching for the IMechE Design Challenge and the Mars rover, for example, so you could have sketches in there.
Oh, okay, I got you.
So that's probably the way to do it. But if you wanted to have a page which was just all the sketching work I've done this year, you know, that would be fine. And that could be a really good way of showing your portfolio. So don't feel you have to have the same pages that we do.
Okay, cool. Thank you.
Hi, Ben.
Yeah.
Regarding to the portfolio, prior to uni, in sixth form I've used CAD software before on SolidWorks. I was wondering if I can include any work from my sixth form years, which I've used SolidWorks, and include that in my portfolio.
Yeah, we've had people in the past show work that they've done from before university or outside university, and that's great. I would just say make it clear this is, you know, when and where you did it.
Okay.
And I think then, you know, it all adds to the employability side of things. But we also know, you know, we're mainly assessing on things that people have done in university, in a university context, because that's what we're here for. But being able to bring other things into the design side of it is somewhere where you could, improve on your portfolio. So I would recommend doing that.
Yeah, so I can do that. Okay, thank you, Ben.
Thanks a lot.
Hi, Ben.
Hi.
Yeah, I'm still a bit confused regarding the the designs we have made as a team. So how do we have to reference those?
I would, you know, I think it is worth having an IMechE Design Challenge page, because then you can be clear this page reflects teamwork, and explain that, and then you could highlight the bits that you think were your significant contributions to the teamwork. So I don't want to, you know, I guess we're saying this a lot, but I don't want to be prescriptive. There could be lots of different ways of showing teamwork. I think usually the best portfolios are clear on what was teamwork. And so I would say, particularly if it's mostly IMechE Design Challenge stuff we're talking about, have that as a separate page, say this was my team, and then highlight the bits that are your strongest contributions and say this is what I did for the team. And one other piece of advice there that again I think, you know, is often advice that's relevant here, is to go and look at what people did in previous years. We've got those examples of portfolios from last year and some examples from the year before, and you could just see how they've presented their IMechE work and see if you get any good ideas from that.
Okay, sure. Thank you.
Thanks. Anything else that people want to ask about or raise?
I have a question about the group coursework, if that's okay to ask.
Yeah, of course.
It's just a question. You know, we have to design the suspension and whatnot. I was just wondering, in our design, do we have to include like all the sensors and lighting and whatnot that the rover has, or do we just do a suspension design and leave it how it is?
Yeah, a few people have asked about this to both of us by email as well. So I think it's really good to kind of get a chance to talk about this. I think what we're mainly saying is it's a kind of mechanical and suspension project. And so, you know, do remember that idea of we're asking you to design it so that when we tow it over a bumpy surface, and it's all defined in the brief what we mean by a bumpy surface, you get minimal vibrations. And I would always be focusing towards that kind of outcome. But if you want to include some electronics, you know, if there are clever things you can do towards that outcome with electronics, we'd love to see that. And if also you think some electronics might help to show some other idea you've got around it, we'll be interested to see what you produce. But I think, you know, if you come to the final presentation and if we come to look at what you produced, and it's got a sort of, this is where 15 cameras would go, and this is where the lights at the front would go, but it's just got 6 wheels stuck on the side of it with no thought of suspension, that's going to be a much less good outcome than something that's a plain box with a very good suspension system and all the work's gone into the suspension system. So if you're looking anywhere, look at the suspension, but there may be bits you want to bring in around other aspects of the hardware. I don't think we'd expect anyone to get as far as thinking about software at all. I don't think this is a, you know, you don't have to do any coding or that kind of thing, certainly.
Thank you, man.
Thanks. Giovanni, was that going to be a question?
Yes, sir. Sorry. It's about Adam's software. Does it have a functionality that it tests electronic inputs as well? If we have an electronically controlled part in our suspensions.
I don't know. I'm afraid that's not something that we cover in this module, which isn't to say, you know, great to use it, and we'd be interested to see it, but I can't help with the details of what's possible with it.
Okay.
It's on my list of things that I should, you know, play with and experiment with, but I haven't got there yet.
I will, you know, if we figure out if there's a way to do it, then.
Cool. That sounds great.
Thank you, sir.
Okay, I think maybe that's a good place to leave things for now. You may find, you know, new questions or thoughts about any of the coursework bubble up in your head over the next hour and a half or so, and feel free to put them in the chat or to save them up for the end, and then we can come back and revisit them then. And I think that's everything we want to talk about coursework. So Alessio, over to you, if that's okay.
Sure. Thank you, Ben. Okay, class. So given that you're working on your respective Mars rover redesigns, and a large part of that is to focus on the suspension, today's class is really just to give you an overview of different suspensions in relation to vehicles. And although the vehicles are very much, I guess, Earth-based, we're hoping that there's going to be some lessons and some, I guess, do's and don'ts and things to consider in the examples that we show you. So let me share my screen and then we can dive into today's class. There we go. Is that showing up, class?
Yeah.
Lovely, thank you. So we're focusing on suspension design, And I guess this is very much the background context to the slides that we're going to be going through together. The kind of holy grail, the ultimate aim of a good suspension is to attempt to have your wheels at the optimum angle on the road surface at all times and under all conditions. It's almost an impossible task to achieve. And there are different suspensions designs that under different circumstances will behave better than others. We'll go through 4 of the main types of suspension design and we'll show you those. And it's a really tricky challenge to achieve as mechanical engineers, as engineers in general. This holy grail of suspension design is the challenge that we're always trying to achieve. So I wanted to start off really by getting some feedback from you guys. We are assuming zero knowledge at this point. And of course, within the group like this, as diverse as this, there are going to be students who are involved in Formula Student who are going to have insights that perhaps the rest of the cohort don't. We've got advanced vehicle engineering students who have chosen their specific course for a reason. But we're not assuming anything here, folks. So what I've done is I've just set up a really simple word cloud exercise where really I'm going to invite you to log into a website and just really share anything that you know about vehicle suspensions. And that can include key components that go into a suspension, different names of suspensions, absolutely anything that you know that you'd like to share with the group, just to help Ben and I just kind of get a feel for the sort of knowledge base that we have in this group. So if you guys follow me, I've got this set up on screen and I hope this works. Has that now shifted to Google Chrome, folks? Can you see a Google Chrome page?
Yes, sir.
Yes.
Lovely, thank you. So if you wouldn't mind, folks, going to menti.com, and entering the code that is at the top of the screen, you should be taken to this page. And the idea is that you can submit more than once. I think I've set it so you can have 6 separate inputs to this word cloud. And just really share what you know about vehicle suspensions, and let's see what comes up. I'd be interested to see what experiences you guys have had, things you may have heard of, etc. I hope this works. Lovely, yeah. So we've got our first colleague in there. Thank you. Oh, fantastic, yeah.
Sorry, so where's the link?
Just at the top, sorry, menti.com, sorry, I should have clarified. So
I think.
Hopefully you see at the top, menti.com, yeah. And there's your code.
Yeah. Thank you.
Oh, wow. It's really nice to see things like drive axle, leaf spring coming up, suspension springs, push rod, dampener, boing, comfort. Yeah, absolutely. I mean, ultimately, that's what, certainly in the vehicles that we are used to, comfort is something that a good suspension system can lead to. And we got things like shock absorbers, so we'll be talking about a lot of this as well. Contact with the ground, wishbones, yeah, we're going to talk about that as well. Yeah, ball joints. There's some really interesting phrases and words coming up here, folks. And it's really nice to see this changing live on screen as well. So thank you for contributing and participating in this. Yep, anti-roll bars. Trailing arm, yeah. We're going to be talking about trailing arm suspensions. That's wonderful, folks. I'm going to leave this up for another 10-15 seconds. Again, thank you so much for contributing. This is great. I'll make sure that this is saved and we'll share this with you on the VLE. Do you know, class, there's so many words that we're going to be going through in the next few slides. And it's really nice to see this. Okay. All right, folks, I think what I'll do is I'll cut it short there. And we'll start kind of exploring and expanding on a few of these points that that you guys have come up with. So absolutely wonderful, thank you. Absolutely brilliant. Well done. Okay. So it was really nice to get your feedback there, folks. I guess if we start with the real basics here, just a few questions on the degrees of freedom. Can anyone tell me, if I shift my cursor to a laser beam, any ideas what this degree of freedom here is called? So hopefully this might tap into some of your intro to mech, possibly from year 1, or some of the dynamics you may have studied before. Any ideas what this is called, folks? I guess I can't check the chat, so let me just quickly monitor that. Okay, we got roll, pitch, and yaw. Well done. Thank you, Peter. Any takers on this one here, this degree of freedom here?
Is it pitch?
Got pitch, yeah, thank you for contributing. What about this one up here? What have we got up here, folks? What's
this is the third one, yaw.
Yaw, thank you. Indeed, that top one is yaw. The front one is roll, and this one is pitch. And the reason for just going through this and just recapping stuff that you hopefully will have already covered is that these dynamic conditions occur in vehicles under certain circumstances, under certain conditions. And this is where the design of a suspension system comes into play. So we tend to get roll, pitch, yaw occurring when a vehicle will accelerate when it brakes, when it corners at speed, when it corners at less speed, and they are reactions to inertia, you know, the tendency for an object to continue moving. They cause the vehicle to essentially rotate around their center of gravity, and that's why we get these dynamic conditions occurring. If we can minimize those in the vehicle that we're designing, it improves handling and improves comfort. So I guess well, it's almost a rhetorical question. What is the best way of controlling these? What do we think, class? If I can just put that question out there, what are some of the things that we can do to try and control those 3 degrees of freedom? Any suggestions, any ideas? Okay, let me just monitor the chat in case we're getting some suggestions there. Okay, so we've got Peter suggesting a 60-40 brake split. Active suspension, thank you, Liam. Yeah. Having a spoiler, yeah. What does the spoiler do, Ahmed? That's an interesting one. Low center of mass.
If we have the weight distribution equally across the car.
Weight distribution being equal, yeah, absolutely, yeah. Adjust your camber, yeah, we're going to explore that phrase. John, thank you for sharing. Anti-roll bars, reducing the height of the center of gravity. Wonderful, yeah. That's great. You're spot on, folks. So these are phrases and things that you've already suggested. So obviously distributing the mass of the vehicle is important. And so that's something that you might need to think about in terms of your Mars rover vehicles. I can guarantee you that NASA would have thought about that very carefully in the launch of their rovers. We want the center of gravity as close to the vehicle center as possible. So we don't want it obviously to one side, to the rear or to the front. And also generally we want to keep it quite low. And this will differ from vehicle to vehicle on the requirements that we're trying to achieve, the objectives we're trying to achieve. But as a generalization, we want to keep that as low as possible. And also reduce the vehicle's mass. Because having extremely heavy vehicles mean that the tendency for the inertia to continue and be greater increases. So by doing those things, we are essentially trying to reduce inertia, and that's a reaction, a resistance to twisting. So the objectives of a good suspension system are really to provide a comfortable ride, keep all of the tyres in contact with the road, maintain optimum traction, and maintain optimum handling. That's really what we're trying to achieve here. See if I can hide that taskbar. There we go, that's better. I'm going to talk you through the four main types of suspension systems that are used in sort of, I guess, domestic vehicles. But there are three main elements that are quite common amongst the different types of suspension systems. Each of these have got pros and cons, and we're going to go through and discuss some of those in the next few slides. The thing to remember that none of the suspension systems I'm going to be showing you are perfect. So it's really just a case of analysing what your objectives are for your vehicle and ensuring that the suspension system that you've selected generally has more pros than the cons for the particular size vehicle that you are developing. One of the things that all of these different systems will have in common is springs. So suspension systems will generally have springs, different types of springs, which we'll discuss in a moment. And they absorb road shocks. Suspension systems will also have dampers, sometimes known as shock absorbers or shocks, and they ensure that the spring doesn't overreact. What you don't want is for the spring to suddenly spring a vehicle back up or you know, after a bump, etc. So having a shock absorber tends to have that slow release. As you're going over bumps, it's just a nicer ride in the vehicle. And finally, there's the mechanism. The mechanism is what controls all the geometry, how all of the different components, including things like the tyres, are all interrelated and connected to one another. So those are sort of like the three main components of any given suspension system. The four types of suspension that we're going to be going through are these ones that you see at the top. So we're going to discuss solid axle suspension beams, trailing arm suspensions, different strut suspension systems, and also short and long arm and multi-link suspension systems. And these, I guess, are the overall overarching characteristics of each type. So starting with the solid axle suspension systems, these are generally used on utility vehicles, slightly larger vehicles. and you'll see that they are designed to carry heavier loads. They're more common at the rear of the vehicle, although occasionally they are placed at the front. The solid beam axle, the solid axle suspension system can have a steering column passing through it. And when the steering column does pass through it, it's known as a live axle. On the other hand, when steering isn't required, those are known as the beam axles. And I'll show you some diagrams to kind of contextualize what these kind of look like. Moving on to the next suspension system, the trailing arm system is generally for smaller vehicles, because it's really, if you imagine a small hatchback car, you're kind of limited for space, and so you can't have some of these bigger suspensions that you see on larger vehicles. So it's more common to see things like a trailing arm suspension system on those types of vehicles. They work particularly well when loaded. They limit the camber. Can someone tell me what camber is? When we talk about this phrase camber, what does that mean, folks? Of my presentation and check the chat. What do we mean by camber? Angle of the wheels, spot on, Jake, spot on, spot on. And just to clarify that, folks, and I hope you now see a blank PowerPoint, fingers crossed, but if we look at, say, the front of a vehicle, oops. If we look at the front of a vehicle and we've got two tyres like this, when we talk about camber, it's this sort of thing, folks. It's the kind of thing that you've probably picked up on if you are a fan of Formula Racing, Formula One, but rather than having wheels or tyres that are completely parallel to one another, camber is the angle of those tyres. Just going back to the trailing arm suspension system class, we can have twist beams located where the pivot occurs. This reduces roll, ensuring that the tyres remain vertical when we're cornering. And this probably will make more sense when I start showing you some of the diagrams, folks. In terms of the strut suspension system, this is very common on passenger cars. I saw on the word cloud that the McPherson struts and the Chapman struts were noted by a couple of students, so thank you for contributing those, folks. The strut suspension system is quite funny. It's if you kind of had limited knowledge of suspensions and you were asked to draw one from memory, the type of suspension you would draw is probably going to look like a strut suspension system. And it's really just because they're quite easy to understand, class. They're very linear, so they're sort of column based. And so you've got, you know, the main column, you've got your shock absorber, you've got the spring. It's all in a nice aligned column. It's quite easy to imagine it. It's easy to visualize it. So if you kind of visualize those types of suspensions where everything is in a column, you're probably thinking of a McPherson strut or a Chapman strut type suspension. Finally, for more performance type vehicles where I guess speed and racing are concerned, short and long arm suspension systems tend to be used. And wishbone suspensions are a variation of that. They're much more sophisticated, much more limited in terms of where they're used. So they'll generally be used on luxury cars, performance vehicles, etc. What's interesting about these short and long arm suspensions is that things like springs we're quite familiar with. You know, we can visualize a spring, you know, it's essentially a coil. I want to introduce this idea of torsion bars and leaf springs in fact as well. So in a moment I'll try and draw a not so poor diagram just to try and explain what those things do. In fact, let's do that now. So if I just shift blank over here, let's just use a slightly thicker pen. So I guess in terms of the usual coil suspensions, you'll end up with your spring. It looks, I guess, crudely speaking, like this. But the thing that I really wanted to show you now was if you had something like a torsion bar attached to your suspension. So let's say this is your tyre here. The idea is that you've got some kind of mount on a knuckle, and attached to that is this big piece of steel. So it's a bar, and at the end of the bar you're going to have your where it's attached to your chassis. So that would be your chassis mount over here. And this bar of steel, it's quite, I guess, a tricky concept to understand, but it's something that's resistant to twisting. So as your wheel is moving up and down, this bar is kind of doing the same thing, but it's taking you back to your home position, if you will, in the vehicle. The other interesting thing that's mentioned is, and we'll be talking about in future slides, is leaf suspension systems. So with a leaf suspension system, you've got your, sorry, I'm trying to do this on an upright keyboard. So if you've got your tyre like so, you end up with a kind of mount on it like this. Let me just change colour for a moment. And the leaf part of the suspension system is a bit of very, very strong sprung steel. Oops. Drawing this upright is a little bit trickier than I thought, but it's a bit like a smiley face. And it's that purple bit that I've just drawn that springs up and down. And if we zoomed in on this area here, the leaf is actually made up of several different types of layers, like so. So it's not just a single piece of metal, it's made up of multiple layers of metal. And occasionally we've had final year projects that have focused on the design and the analysis of leaf spring suspension systems, just looking at different materials that could be substituted for the general sprung steel that's used for those. But I guess this crude diagram is something that I'd like you just to keep in mind when we talk about the leaf spring. Okay. And then just a final note on this slide is, in terms of the positioning of coils with your short and long arm suspensions, when it comes to race cars, because aerodynamics are really at the forefront of all the thinking, obviously coils being positioned in their normal sort of upright position can tend to add drag and air resistance to the vehicle. So the short and long arm suspension system does allow for those springs to be positioned longitudinally, and that aids the aerodynamics of the vehicle as well. Excuse me, folks. I've been talking a lot for the last few weeks, so my throat's finally given up. So if we go through some of these suspension systems now and just provide some different examples under different loadings. Let's start with our first example, the solid axle suspension system here. So bearing in mind this is generally used for heavier type of vehicles. The images at the bottom will explain how the suspension system will behave under different loading conditions. And I suppose the thing to be thinking about here is just on cornering what's happening there, because that's probably the main downside to solid axle suspensions. If I were to switch back to this, because I like drawing, if you wanted to kind of, I guess, try and remember the four types and what they look like, the solid axle suspension system is sort of summarized a bit like this. So if at either end of your vehicle, you've got your tires, these are your two springs. Either side of those springs, you'll end up with your kind of shocks. The thing to always remember with this type of suspension is the solid beam is this thing here that I'm drawing. So always try and remember that solid axle suspension systems are kind of what they say on the tin. It's that solid bit there that connects the two suspension subcomponents. So going back to our slide deck, let's just have a look at the diagram here and see if that helps explain anything. So either side here, you'll have your springs, your shocks, but it's this really solid bit in the middle that defines what the solid axle suspension system looks like. The control arms are connected to the body of the car. So what we've got here is a system that's really quite low cost. It's strong. It's really super strong. It's also something that enables us to encase the differential. Does anybody know what the differential does on a vehicle, please? And I appreciate this doesn't may not be one of the at the forefront of your thinking for the Mars rover, but would be worth sharing. What does the differential do, folks? The chat.
It transmits the power equally to the both tires, I guess.
Yeah, straighten the speed for stability. Yeah. Well done. Yeah, Dewey, well done, Dowie. Yeah, it allows the wheels to turn at different rates. Yeah. Yeah, that's great. Absolutely fantastic. Yeah. So just this component here, folks, that you see at the back, the differential casing is quite important when it comes to vehicles. It converts the engine power to the wheels, first of all. It also acts as the final gear reduction. But when a vehicle corners, folks, remember that the tyres on the inside of the cornering is going to be spinning at different rates to the tyre on the other side of the vehicle. And so the differential will split that gearing ratio between the two sides of the tyre, essentially. So it's an important piece of kit. And the solid axle suspension system allows us to mount that onto the vehicle, onto the suspension. This example here is where we've got the solid beam appearing exactly as it is as a solid beam, but there are variations of the solid axle. The ones without the coil spring. So instead of the coil spring, we've got the leaf springs in this example here. So we've got the shocks as we did in the previous version, but the coil spring is replaced by these different types of springs. So this is where we've got leaf springs. We've got a similar setup here, but on this example on the far right, I want to introduce this component here, which is quite interesting, and it's the panhard rod. And the panhard rod is essentially just a very strong piece of metal, really strong piece of steel. One end of it is connected to the solid axle, and the other end of it is connected to the car body, to the chassis. And essentially it limits the amount of sideways movement, the amount of lateral movement that the suspension system has. So again, that's Well, it may sound crude. It's a very effective way of, as the vehicle is bouncing up and down, etc., there is this tendency for lateral movement to creep in, and it's a really efficient way of limiting that movement. For our smaller vehicles, we've got trailing arm suspensions. So the trailing arm suspension looks like this kind of L shape. And in fact, in a moment, I'll add to my crude drawings just to kind of get you to memorize what some of these look like in sort of diagrammatic form. Just remember that the trailing arm suspension systems are really adapted for smaller vehicles. And here we've got the different loading conditions for trailing arm suspensions. So when we're on a curb, right through to when we're cornering, this is how they'll behave under those different conditions. In terms of the crude drawing and how to try and remember these, if I switch color to something else, it's pretty much just mimicking what was on the previous slide. So you've got your vehicle tire, so, and then you tend to have your spring, and it's then eventually mounted. And this is the trailing arm bit that I'd like you to kind of memorize in your heads. And this is the point here where the trailing arm is connected to your vehicle. And this, of course, then will be bouncing up and down. So if you kind of imagine this crude sort of L shape, a reverse L shape, the trailing arm suspension system looks like that. Let's have a look on the diagrams now, see if those clarify that a little bit further. So the trailing arm in the example on the left, just switch back to my laser. This is where the trailing arm is. You've got your suspension mounted on top of it. You've got your shock absorbers mounted internally as well. And the two sides of the vehicle are then connected by this twist beam, which was noted as well on the word cloud that we created earlier on. So the twist beam is again just a very big piece of steel, very strong sprung steel, and it's sometimes known as the anti-roll bar as well. And the twist beam will, as the suspension, as the parts of the vehicle move up and down, this twist beam is the thing that helps kind of get back to a home position because of how solid it is. The example that we've got on the right, the twist beam is replaced by something very similar, known as a torsion bar. So with torsion bars, on the twist beam you've got the two sides connected. With the torsion bar, they're not actually connected. So I don't know if you can see that, it's very subtle, but you've got one torsion bar that kind of comes to about this point. It doesn't connect to the other side. And then that's connected to your vehicle. And then the other side, likewise, you've got a similar setup. And there's a slight difference in terms of where the shock absorbers are mounted on this example on the right. Flexing seems to be a big issue with these suspensions, and sometimes that's why we have these smaller triangular options as well, which are just a version of this here. If I move on to that slide there. So with the two of them being separated like this, they're completely independent of one another. And the trailing arm is this kind of very strong triangular structure that you see on the image on the left. The image on the right is just another variation for the rear of the vehicle, so wherever this is adopted on the rear, and it's also introducing that panhard rod system which connects to your vehicle chassis. But here you've got your trailing arms here, and then you've got your pivot axis going through the two of them. So depending on specific objectives of the vehicle, depending on where this is going to be positioned, whether it's front or rear of the vehicle. These are the different variations of trailing arm suspensions. The strut suspension system is the kind of, I guess, I'm going to call it stereotypical suspension. So if you had to kind of imagine what a system looks like from memory, this is the kind of thing that certainly I would probably draw from memory before I knew much about the different types of suspension. It's just something that works. It's just very efficient. Most road vehicles will have this kind of suspension system, known as McPherson struts or Chapman struts, depending on whether they're at the front or the rear. And I'll show you the difference between those in a moment. So with these different suspensions, the different loading conditions can be seen in the diagrams down at the bottom. And the difference between the McPherson struts and the Chapman struts is whether we want to actually steer via those columns. So steering is the differentiator. But again, just trying to give you a little bit of a memory jog, I hope. So it's really just drawing the column for this particular one. So if you've got your tyre on the side, like so, and then you've got your mount for your system, your suspension, and then there'll be some kind of knuckle down at the bottom of that. That would be your shock, and then that would be your spring. And so with this particular system, it's all aligned in the same column, so quite easy to remember. Just go back to full screen. And here we've got a couple of those examples. So if we focus on this image here on the left for now, there we've got the tyre connected to our spindle, and we've got a little steering knuckle, and everything is aligned in this column here. The thing to really pay attention to is that this is where the steering axis will pass through. So with our McPherson strut, which is what we've got here, we can steer. So if you imagine the steering column down here, it then enables us to steer the vehicle. So this is why it's generally used at the front, generally. We've also got the Chapman strut, which is the example that we see here on the right. There's a slight variation in terms of the positioning of these lateral links, but there's nowhere for the steering axis to go through. And so this is known as the Chapman strut, and this is the typical layout for that kind of setup. And if we move on finally to the short and long arm multi-link suspensions, this is very similar to wishbone suspensions on Formula Student and Formula Racing type of vehicles. Remember that this is the sophisticated performance vehicle type suspension, but there's something to be learnt from the way this is set up. With the short and long arm multi-link suspension systems, the short and long arms are these components here, which hopefully you can see the laser pointer just hovering over. Same down here. So here you've got your long arm, here you've got your short arm, and then in between those you've got things like your spring, your shocks, etc. passing through. These in diagrammatic form. This is what they look like. So if you've ever seen a wishbone in a chicken, suspensions, because they look very similar to a wishbone that you find in a chicken. And these are your arms. So you've got your arms down at the bottom, you've got your arms up at the top. In this system here on the left, you've got these torsion spring bars. So those are connected to your vehicle. And again, as you get twisting action occurring as you go over bumps and little hurdles, these torsion bars will twist back to a kind of home position. So very effective way of getting suspension back to home positions. With this variation that you see on the side here, this you can see that it's almost like a combination of the double wishbone combined with a strut type suspension system, just like we saw in the previous diagrams. So here, because of the space enabled from the short and long arms, we can actually mount suspension coils and shocks right through the middle of them. And this rather big beast that we see at the back at the end, this is, believe it or not, a multi-link suspension system. It's known as a multi-link because of the fact it's got more than 2 links. It's very discreet to see, and we'll make sure that these slides are made available to you, class, but there are 3 links actually from the steering spindle and knuckle. We've got one over there, one over there, one over there. And so with the multi-link system, we've got multi-links. We've also got this whopping big piece of solid axle type mounting. And the reason that this is such a great suspension system is the fact that when it comes to some performance vehicles, we're very limited with space. And so this is a design that's been developed to really encompass things like the differential and other elements of the vehicle, such as anti-roll bars, anti-sway bars, plus your suspension, all in one big solid block, leaving the rest of the vehicle, well, the rest of this area here for space, essentially. And so you can have quite low riding vehicles as a result of this type of setup. So while it looks like it's very busy, and it is, and they're a nightmare to build and a nightmare to mount, in terms of space saving, the benefits are huge. Yes, in terms of next steps, folks, we'll open this up to comments from you guys, and we always want to kind of pick up on what you guys have experienced in your own careers and lives, etc. So we'll do a bit of a share and tell in a moment. But in terms of next steps, folks, just going back to one of the things we mentioned right at the start of coursework 4, which was really start to understand things like the rocker bogie suspension and the differential pivot that's on the JPL lab website. Those are 2 key elements for you to really get to grips with. And what we're hoping is that by revisiting some of these slides, revisiting some of these diagrams, that you may be able to kind of pick up on things that potentially could be integrated into a couple of these things. And as a result of that, maybe developing something that just performs a little bit better for your Mars rover designs. There's some references as always, so there's a few interesting bits of reading that we'd recommend. So if you are sort of interested in different types of suspension, there's a lot more information in some of the key text that we're sharing here, folks. On that note, let me just revisit the chat and see how you guys are getting on. Have we got any questions, folks? Was there anything, Ben, in the chat that we need to go back and revisit?
There's a really interesting question from Agnes in the chat about how we can link FEA to suspension design.
We'd love that.
I guess there are 2 sides, I think, to my understanding of that. The first is you can look. FEA is good at looking at statics problems, and less good at looking at dynamics problems. To some extent, suspension design is a dynamic problem because things are bouncing all around. But one of the things you can do is to try and find out how much bouncing you expect. And one of the ways that people sometimes describe that is in terms of G-forces. And so if you have 2G being experienced by the body of the vehicle as it bounces around, then essentially the suspension is supporting twice the weight of the vehicle. That's the kind of way that that works. And so you could do FEA where you deliberately load it up with those equivalents of high G-force and see how much the suspension deflects. And then that might tell you how much you expect it to bounce up and down when you're going over bumps. And the reason I was particularly interested to talk about that is because I've just been talking today to a new startup company, and they do artificial intelligence stuff using video footage from bicycles. So that I guess part of what they're offering is if you have an accident on your bicycle, they'll be able to say this was the cause, this was the car that hit you, I guess, or that kind of thing. And so they're very interested. They've got their camera mounted on a special sort of cargo mount on the bicycle. And the one thing they really don't want is that the camera bounces up and down, because then you've got a slightly different, the video gets bounced up and down as well. It's much harder to make things out. You'll get video blur and everything else. So the way that we've been solving it is to go away and try and find the G-forces that are acting on a bicycle as it goes over normal bumps. And there's a paper from a research group in Southampton who just measured that directly. They rode a bicycle all around all day with accelerometers on it. And bicycles go up to about 2G of vertical acceleration as they go over bumps. So we figured the maximum deflection will be about the deflection caused by double the weight of the object on the end of the arm. Anyway, all of that is a way of saying you can take a kind of instant snapshot of the dynamics and do FEA on that snapshot and find out how much you might expect things to move by looking at deflections. But a full answer is always going to have to also consider the dynamics. And that's a harder problem, and one that, there are different ways to look at it, but there's probably not going to be one complete answer of what the dynamics of suspension are going to be. So some physical testing is always good there as well.
Yeah, but really good question, because it immediately got me thinking, Agnes, that a lot of the decision making we want to see evidence of, if it can be data driven. So if there's some kind of analysis, some kind of building of a prototype, we just want to see that it's not just been randomly thought of, that there's some kind of data and some reason behind the decisions. And I guess it goes for mechanical engineering, advanced vehicle engineering in general. We don't do things by chance. We want to do things for a reason, and we want the data to be driving the decision making. So if you can show some evidence of that, that's always a positive thing. I don't want to pick too much on Formula Student team members, but I'm aware that we've got a fantastic team captain here amongst us and a fantastic team. And I just wondered, from the Formula Student team perspective, has there been any kind of analysis of the suspensions? Sorry, I'm losing my voice, folks. My throat's struggling a bit. Has there been any kind of analysis on the vehicle, Giovanni or team?
Yes, of course. So I guess first thing we did when designing the suspension was first go through the calculation. So we set up an Excel spreadsheet starting from the outside. So it is always suggested to start from the tires, examine the wheel rate, the tire sorry, yeah, the tire rate, and then we did a bit of calculations, got more or less in the area we want it to be, and then we use Lotus Shark to analyze, to simulate a bit the suspension we had designed, and we went for double wishbone at the front and trailing arms at the back.
Fantastic.
If
Thanks
you'd
for
like,
sharing,
I'll just share a
Giovanni.
couple of images.
But it sounds like it was very much going back to pen and paper and calculations initially, which is good to hear.
Yeah, it was quite good.
Well done, team.
There's a question from John in the chat that I might just, I was going to start typing and then I thought maybe it's easier if I start talking instead. I think that's a good point, that we've said you shouldn't lose any functionality over the JPL model. The JPL model has a lot of functionality, so necessarily when you shrink things down, I think you will lose functionality, and maybe we should think about tweaking that wording for next year. I think what we mean is the suspension design that's in the JPL model has been carefully designed, and if you can find ways to keep that level of suspension or that level of ability to go over bumps, then you'll do very well in this task. But you're right, it's not about things like having motors on the wheels or cameras or anything like that. It is just as you scale it down from the JPL design, try to keep the things that work well for suspension within the JPL design. I think that's a better way of putting it than what's in the brief, actually, and thanks for highlighting that. And another good question, is there a set speed at which the models will be pulled or towed? At the moment, we don't have the rig in place. But I think if you aim for 1 centimeter a second, let's say that's going to be the towing speed, and we'll set it up if we can to run at that speed. There was a question from Stephen too about where do you find the CAD files, I think. I've got the oh yeah, brilliant, if you can, great.
Sure. So Stephen, always go back to the VLE, and if we go to coursework 4, you'll find that there's a link to JPL's open source Mars rover. So if you click on that link, and eventually it'll take you to, it's got a couple of links, but the first one that you come across, and it will take us to this page here. Apologies, it's taking a while. Okay, and then right at the top, if you go to get started, and if we click on see the plans, it will eventually take you to a GitHub website, and this is where you'll find all the different parts. So start off by going to mechanical. So there's a mechanical folder, and then you've got different assemblies here. So for example, if we look at rocker bogie, if we click on that, you should find that there's a CAD folder within each of those. So if we click on CAD, and then download one of those assemblies, you don't need to download all three. They're in different formats, so one's an IGES, one's looks like a SolidWorks assembly, and the other one is a STEP. So you only need one of those to download, and that will give you the rocker bogie assembly. And then it's a case of just getting the rest of those together as well. So it's all on this this GitHub website.
Thank you, Alessio.
Does that help, Stephen?
Yes, thank you very much. I didn't know it was in different files. I thought it was just all in one file, so that's why I was confused. Thank you.
No. Oh wow, Fantastic, Giovanni. That is really great to share. Class, given the different experiences of people in this group, because we are a nice diverse group, is there anything that perhaps from your own experiences that anybody would like to share in terms of suspension design from maybe past courses or things that they've experienced on, you know, their own vehicles or AVE vehicle students? Anything that you'd like to share? We'd love to kind of create a little bit of a knowledge community here, folks. So feel free to either unmute your mics or share in the chat, because I think now's a great time to be talking about this. Anybody ever had to dismantle or put together a suspension on a vehicle? Oh, brilliant. I didn't know that, Zia. Is that as part of your industry work? Wow. Peter as well, wow. Peter, I'm putting you on the spot, and Zia as well. Anything you'd like to share with the group from your experiences? Because there's nothing like that kind of hands-on experience. Anything you'd like to make the group aware of, or just, I guess, share anecdotally?
You're doing it's a lot of trial and error setup. Even you come into things like bump steer, corner steer, corner weighting of cars, and how the actual car is set up. So even where you've got the shims on suspension, where it sits within the mount, you can actually move it backwards or forwards based on the washer setup. So actually the suspension is no longer straight on an axis. It's a camber and an angle, but also shifted forward or back. If you go further into stuff like NASCAR, because obviously it's a left-hand circuit, the car will be set up differently. So when you're driving it on a straight road, it will want to pull to one side because the angle and the bank of the track. And I was just the different weights of the cars, different styles, whether it's mid-wheel drive, there's quite a lot that goes into it. It's quite complex, but almost going back old school way with actually setting up the camber, and the tier was almost done with a piece of string and checking it with a rule, because you could then work it out. You can use laser lines, which something like QuickFit would use or something like that, but actually a lot of it was really kind of minor tweaks, take it out, test it, come back, and then record exactly what you've written, but it would change from car to car. Also, how heavy the driver was affected quite a lot as well.
Yeah, it's fascinating to hear that kind of that trial and error, because again, you're using data in a slightly different way than what we've been speaking about in terms of software, but you're still kind of trying something, getting some data, getting some information from the real world, making a change, trying it again, making a change, trying it again.
You probably get a bigger impact on go-karts and setting up, because obviously it's a fixed rear axle, it's no suspension, and that is literally done on bushes and shims, as opposed to a race car, which is quite a, you know, you've got some big setups there and different money.
Yeah. Thanks for sharing, Peter. Zia, I'm fascinated. I didn't know you worked at Toyota. Anything you can share with the group that would be of use to the coursework, or any anecdotes?
Well, whatever what's his name, Pete just said, it's basically the same thing, sort of trial and error. to be honest with this here. Like you cannot just go and straight away it's gonna be, you know, you're gonna get what you want. So there's a lot of trials and error, suspension wise as well. If you want to change the suspension, you're not putting the general one on, you're changing the suspension to alter the ride you want. So that's a lot of trials and error, and a lot of people waste money trying to get what they want.
Yeah. Wow, you'd almost think that Toyota had some secret that, you know, some magical software that just did it for you, but no, it's very much old school, trial and error, try things out.
Pretty much, yeah.
That's I think that's still a good message to be sending out, that you don't just stumble across the answer straight away.
Well, it's all experience, isn't it? The more you do it, the more experience you get, less trial and error.
Thanks for sharing, Zia. Yeah, good point, Ben. Yeah, good point. I suppose, folks, in terms of the content for today's class, the main lecture was very much about suspension design. We'd recommend the rest of the time, what do you think, Ben, the group focusing on their coursework assignment?
Yes, I think that's right. And I mean, I think, again, we want to be able to answer questions about the Mars rovers and the portfolios. And so I think a bit of time in groups talking about your Mars rovers now, and then coming to us with questions is the best way to develop this suspension idea right now while it's fresh in your mind. I've just seen another question come in. I guess I can answer Liam's question again. It's easier if I speak than type. Keep focusing on, you are trying to build a vehicle which will, when towed over a bumpy track, minimize the acceleration. That and use the Mars rover as inspiration. That's probably the best way to balance it. I'm getting a message about bad network quality, so sorry if this is choppy, and I'll put it in the text as well, just so it's clear.
No, got it. Thanks, Ben.
Great, thanks. So yeah, I mean, I guess if everyone can discuss now with their groups about how you can incorporate any of these suspension designs into something that you can actually make on a scale with wheels, whatever size we said they are. I mean, they're about that big. So not much bigger than a £2 coin, I think. How can you actually build any of these suspension systems on that scale using the kinds of things that we have available in the workshops and labs, or even that you've got available at home right now? That's the kind of brainstorming and ideation that we want people to do, I think.
Also, class, we've reached kind of extra time, almost at penalties for the groups. So final shout out, I'm just putting it in the chat, but please let us know if you don't have a group. Ben and I will finalize this imminently. So thank you to most of you who are in a group. I'll just put that in the chat. So if you're not in a group, please say so in the chat, folks.
Question from Agnes says, can we 3D print? And the answer is yes, absolutely. And in fact, one of the first, I think I'm right, Alessio, one of the first things that's become available in terms of workshop stuff that can be done is that we can ask workshop technicians who are in LSBU to laser cut or 3D print from our designs. And so we'll talk, I think maybe we've got a lecture for this semester on workshops and prototyping and everything else. And maybe the most helpful thing is if we do that next week, then we can explain the processes for all of that. But the short answer is yes, you certainly can 3D print. And in fact, that seems like a good way to get things working.
Yeah, in fact, Ben, let's do that. Next week, shall we go through vehicle history and also workshop?
Yeah.
Yeah, let's do that. I'm just getting up the groups list.
For the question for the 3D printer at the school, do you know what type of filaments are available, or will we have to email them to ask them?
If I just jump in, if you look on Moodle, it might be slightly out of date. If I just go to my Moodle, I'm going to share my screen. Down at the bottom of my Moodle, which is a bit long, sorry, but I think everyone else should have something similar. There's a page called LSBU Engineering and Design Workshops, and I hope other people can see that. And then you can start to find some information about what's available in the workshops here. And for example, if you go to B30 Additive Manufacturing and Laser Cutting, then you can see that it's run by Tony Hope. And there's a picture of him, but there's also information about what the different 3D printers there are. And I hope somewhere it'll tell you. So the standards are ABS or this photopolymer with similar properties to ABS, I think. But yeah, the materials are all listed on that page, so that's where to go and look. And again, we'll talk a bit more about that possibly next week.
Okay, cool. Thank you.
Thanks, Ina. Onye, I've just noted you don't have a group, Onye, so I'm trying to find you one. Can I just check, Belik? I think you hinted in an email you had a fourth group member, Belik. Do you know who that is? If you could let me know, I can add that person. Okay. Okay, thanks, Dylan. Belloc, who is that fourth group member? Could you let me know the name, please? Thanks.
Okay, now that we are sorting out groups for coursework and things like that, I think I'll stop the recording. But if people continue to have questions, you are always welcome to keep